Welcome to The Explainer. Today, we're talking about a fuel source that could change everything. One that the world basically abandoned during the Cold War. But now? Well, one superpower is betting billions that this element, thorium, is the future of energy.
So, where does this all start? It kicks off with a really big announcement coming out of China. They're making a huge strategic bet on a next-generation energy tech, and honestly, it's got the rest of the world paying close attention.
And they've even put a date on it, 2029. That's the year they're planning to flip the switch on a brand new, revolutionary type of power plant. I mean, we're talking about a project that could completely reshape the global energy landscape for the next 100 years.
So what is this thing they're building? Well, it's the world's first operational thorium reactor. And, that's a big deal. This isn't just some experiment in a lab anymore. This is the real thing.
Okay, so this first plant, this prototype, it's actually pretty small relatively speaking, but don't let the size fool you. Its purpose is massive. The whole point is to prove that this fuel source, the one the world gave up on 50 years ago, actually works in the real world. The dream to one day power entire cities with clean energy.
And make no mistake, this is not just a one-off experiment. It's really the first move in a much bigger strategic plan. Just look at that last point. China thinks it has enough thorium to power the entire country for, get this, 20,000 years. When you hear a number like that, you start to understand the sheer scale of their ambition here.
Which, of course, brings us to the star of the show, the fuel itself. What exactly is thorium? And why do some people talk about it like it's this revolutionary, almost miracle solution to all our energy problems? All right, so what are we talking about here? Basically, thorium is a naturally occurring radioactive metal, but here's the key thing you need to remember. It's incredibly abundant. I mean, to put it simply, for every ton of uranium we manage to dig up, there are about 3 tons of thorium just sitting there waiting.
And when you put it side by side with uranium, the difference is just, wow, it's stark. Think about the 3 big worries with nuclear power, right? Safety, long-term waste, and the risk of it being used for weapons. On all 3 of those, thorium looks dramatically better. I mean, a reactor that's physically incapable of a meltdown, that produces way less dangerous waste, that's not just a small step up, that's a potential game changer. So that leads to the big question, right? The central mystery in this whole story. If thorium is so great, why on earth aren't we using it already? Why did we basically put it on a shelf for 50 years and go all in on uranium instead?
Well, the answer, it turns out, has less to do with the science and a lot more to do with the geopolitics of the Cold War.
So, if you look at this timeline, you can see thorium was a really promising technology back in the 60s. The US was even running successful experiments. But then came 1971. A single decision changed everything. See, the US government wanted a power source that also happened to produce plutonium for its nuclear weapons program. Uranium reactors could do both. Thorium couldn't. And just like that, politics beat out technology, and thorium got pushed to the sidelines for decades.
Okay, so now that we've got the history, let's get into the tech that China's bringing back. How does one of these thorium molten salt reactors actually, make electricity? Let's break this down. First, you take the raw thorium and you process it into a usable nuclear fuel. Then, that fuel heats up this big tank of molten salt to crazy high temperatures. This superheated salt, and this is a key part of the safety design, is then used to boil water. That creates steam, the steam spins a turbine, and boom, you get electricity. But here's the part that's going to blow your mind. The reaction can actually create more fuel than it uses up. How incredibly efficient is that?
But okay, before we get too excited and declare thorium the perfect solution for everything, we need a little reality check. There are some very real, very big challenges to overcome. This is definitely not a simple fix.
So there are really 3 major hurdles here. First, the cost. Building one of these things is insanely expensive right now. Second, the material science is just incredibly difficult. I mean, think about it. You have to contain this super corrosive radioactive salt that's also super hot. Finding materials that can actually handle that for decades is a huge scientific puzzle. And finally, while it's tough to do, the risk that someone could weaponize the byproducts, well, it's low, but you can't completely write it off.
But even with all those challenges, the potential reward is so massive that you have to ask the question, are we looking at the future of energy right here?
This chart really gives you a sense of the global scale we're talking about. And notice something interesting. Countries like Turkey, not the usual energy giants, are sitting on some of the biggest known reserves.
This could completely redraw the world's energy map. It could give energy independence to nations that right now have to import all their fossil fuels.
And this quote just nails it. The 21st century's new oil could be thorium. It perfectly captures the kind of paradigm shift we could be looking at. We might be on the edge of a totally new energy era, one powered by an element found all over the world, not just in a few specific places.
So, when you boil it all down, what's amazing is that the basic science behind this has been understood for over 60 years. The real roadblocks now aren't really about the technology itself. It's about having the national will, the vision, and being willing to make a huge long-term investment to make it happen.
And that really leaves us with the final question. With countries like China pushing ahead, they're basically forcing everyone else to make a choice. Is this the moment to lead, to follow, or to risk getting left behind in what could be the next great energy revolution? It seems like that choice isn't just a hypothetical anymore.